we've got Hannah Cummins, and Hannah is going to talk about the effect of single and split applications of plant growth regulators on industrial hemp. And we'll get her slides up in a second.
So thanks, Beth, for that little intro. Today I want to give you a bit of background on the Tasmanian hemp industry and really talk about one of the significant challenges growers are faced with in that industry. And it's really around the harvestability of the crop and the large amount of fibrous stem byproduct that we left with after the seed harvest. So that brings us to the potential of using plant growth regulators, or as I'm going to refer to them as PGRs, to kind of address those challenges. We'll have a look at the results from my field trial and have a quick chat about what that might mean moving forward. But first and foremost, I want to say a huge thank you to everyone that was a part of my honours project that provided lots of support, the industry organisations and businesses that provided financial support to the project are listed here on the slide. So hemp is a relatively recent addition to Tasmanian cropping rotations, and really that's been on the back of the Tasmanian Industrial Hemp Act in 2015 and then recognition of hemp as a food product in 2017 by FSANZ. So you can see on the graph there how production area has continued to increase. So hemp is a favourable crop. It's suited to our temperate climate here. It will grow on a wide range of soil types, and really it has this short growing season allowing it to be incorporated really nicely into our rotations. In 2019, Macquarie Franklin said that at $3 a kilo, a 1 tonne to the hectare hemp crop would compare in gross margins quite favourably to that of other grain crops. But with every good thing, there's always some challenges, and with hemp, that really revolves around the high genetic variability. So plant height can range from 0.8 to above 2 metres, and then within a single crop of one variety, you still get a lot of variation. To add to that, hemp has a fibrous, woody, rigid stem that's quite difficult to deal with and really creates these challenges in the harvestability. To add to all this, the Tasmanian industry has focused predominantly on seed production. So in the seed production system, the fibrous stem that we're left with after harvest has no use. Being a tall crop, we have a lot of it. The stubble's too tall to direct drill straight into, and then the fibrous nature of it wraps on machinery and conventional ground preparation. So that's led a lot of growers to resort to burning hemp stubble post-harvest. So I guess really if we want hemp to be a long-standing part of our rotations, we need to address these challenges around harvestability and efficiently moving the hemp paddock into the next crop of the rotation. So that brings us to the potential of PGRs. So PGRs are chemical products that are applied to plants to modify them in a desirable way. So many of you might be familiar with the use of PGRs. They've been used a lot in the poppy industry and also on cereals and grass seed crops, really to reduce plant height and prevent crop lodging. So I guess the idea here is that if we could reduce the height of hemp, we could have less fibrous stem to deal with afterwards. Maybe we could make it short enough to be able to direct drill straight into and really address these challenges that I've just talked about. And then of course, what's the impact of PGR application going to be on seed yield? So we set up a field trial that was located within a Midland seed crop of CFX2 grown at Hagley. And I looked at 4 commonly used PGRs. Now, at this point, I really want to point out that hemp isn't on the label of any of these chemical products, so all of this was off-label under experimental conditions. And that just means that moving forward, if anything was to be adopted by industry, you would need to have an APVMA permit for application. So the PGRs that I looked at were Uniconazole, that's been used a lot in the poppy industry, Trinexapac-ethyl that's sprayed on grass seed crops, Paclobutrazol that's used on cereals, and then Paclobutrazol, which was a bit of a wild card for this project. It's actually used a lot in perennial horticulture, but we thought we'd see what happens on hemp. So I applied everything at maximum label rate. Now, some people suggested to go higher and really see if I could get a response. But I stuck to max label rate because I knew that if I found a miracle cure at 3 times the label rate, we'll never get a permit. So that was the real reason we stuck to max label rate. And then I applied everything as a single and as a split application. So there's some literature out there that suggests that a split application could extend the period of growth regulation, but there's other people that fail to support this. So I set up a split plot design with 4 replicates in the field. The first of the split application went on at the 4th leaf pair, and then the second of the split and the single application went on at the 6th to 7th leaf pair. Now I want to really step you through what we saw throughout the growing period in plant height. So these graphs are of plant height, the controls, our yellow line, and then you've got the single and split application. I've also popped some photos in here that were taken 10 days after the second of the split and the single application went on, just to give you an idea of what things were looking like at the trial site. So Uniconazole was quite exciting, and we saw that height reduction that's been seen in other crops previously. And to add to that, it was really quick. So we saw the response within 3 days of application, and the split application actually reduced height further. However, once we get to the end of the growing season there, you can see them come back together. I guess the opposite kind of happened with Trinexapac-ethyl. So in cereals and grass seed, it's reduced height. We saw a trend of increased height, which is in contrast to that literature. To add to that, we also observed yellowing. So yellowing is seen in cereals when TE is applied and the plants are stressed. However, normally they grow out of it. For us, the yellowing was there kind of within 5 days of application, and then I have NDVI results 14 weeks post-sowing that still bring up this yellowing. So we did a tissue test. Now, I need to point out that the tissue test wasn't replicated, so it's really preliminary data, but we did find low levels of ammonium. So maybe we're seeing some nitrogen deficiency here. This could be a dilution effect. As we've increased height, we've ran into nitrogen deficiency. But I guess either way here, TE hasn't shown any potential to address those aims that we mentioned. Then we get to Paclobutrazol, and really we saw limited effect. There's been successful height reduction in both perennial horticulture and annual crops, but in this trial on hemp, we really found nothing. And then we get to Chlormecoquat. Now, again, in the literature, there's been height reductions, and here we see a couple of points where there is, but there's also a lot of overlap. So I want to bring you to this graph. This is the plant height at harvest, which is ultimately the most important. This is when we determine the harvestability and how much stem we're going to be left to deal with after harvest. So we measured an increased number of plants at this point and really brought out some of those trends. So we've got a 12% reduction with Uniconazole, 6% with Chlormecoquat. We see that increase of 7% with Trinexapac-ethyl. So I guess a concern of using PGRs on hemp could be an increase in stem diameter. So PGRs are often used to reduce crop lodging, and in doing so can thicken the stem. But the literature around this is quite inconsistent. For us, we saw pleasing results, and we actually had a reduction with Chlormecoquat, Paclobutrazol and Uniconazole. So as much as this is statistically significant, it's within 0.5 millimetre, so there was definitely no implications of this. And the real message I want to share here is that we haven't increased stem diameter. And that brings us to seed yield. So seed yield increases following PGR application are well documented in the literature. And a lot of that is attributed to the fact that they've reduced plant height and in doing so prevented the crop from lodging. So when they've prevented the crop from lodging, they've effectively been able to harvest more seed, and that's where they're getting their seed yield increases from. For us in hemp, hemp has a tap root, it doesn't fall over, there's no risk of lodging. So by reducing plant height, we're not increasing the amount of seed, we're not saving any seed that would get lost. So that's a major reason behind the fact that we haven't seen any difference in seed yield, and we've also seen no difference in the 1,000 seed weight. So in conclusion, uniconazole and chlormecoquat both reduce plant height at harvest, and that height reduction can potentially aid in increasing the efficiencies of harvestability and reducing the amount of fibrous stem that we have to deal with after the seed harvest. Trinexapac-ethyl increased plant height and Paclobutrazol had no effect. The PGRs that we looked at didn't increase stem diameter, which I think is crossed off a concern. I think if we increase the stem diameter of hemp, we could be running ourselves into more trouble than we're getting ourselves out of. And there was no difference on seed yield or 1,000 seed weight. So moving forward from this, uniconazole and chlormecoquat have shown the most potential here, and there would definitely need to be additional research to really work out the rates and the timings of application to confirm the commercial suitability of this, and then of course to source APVMA permits. So this is a list of the references that I've referred to in here. Thank you all for your time today, and does anyone have any questions?
Awesome. Thanks, Hannah. Just to be very clear, that picture was taken prior to COVID, so if anybody's worried about that.
When we could all be friends.
Yes. Has anybody got any questions for Hannah? Sergey? So what Sergey's asking is whether it would be easier to breed dwarf hemp rather than using PGRs.
Yeah, so here in Tassie, because we're growing for seed, we actually grow seed varieties, and believe it or not, apparently they're shorter than the fibre varieties, but they're still not short enough for our liking. You can still get lost in them. So I guess for that reason, we're looking at PGRs. It's actually been a question that has come up at field days and things like that previously, and that's really because a lot of growers are really familiar with the use of PGRs. So they kind of spray them on everything else. They're a bit like, could we be spraying them on hemp too? So that was really the aim of the project. I think definitely if we could breed, or if we could get a variety that was short enough, I think that would solve everyone's problems. And it's always nice if you don't have to load the spray rig an extra time. But for this project, we thought it was still worth looking at with the varieties that we're using here in Tassie.
So what Adela's asking is whether one can harvest the stubble and make fibre from it.
Yeah, so the Tasmanian Hemp Association is actually doing lots of work in that space and looking at if we could actually do something with the fibre. For this project, we were really looking at our big-scale growers that want to grow a grain crop. That's where the demand is at the moment, that's where the market is, and they want to be able to quickly get that paddock into the next crop of the rotation. So they need to, somehow we need to we need to improve the efficiencies so that we can get it straight into the next crop. But 100% there is lots of work about if we could use this fibre, and just at the moment it's still very small scale and in its infancy, so that's kind of why we still went down this path to see what options were here. Yeah, 100%. Yeah.
Happy. So what's being asked is around whether there are other ways of reducing plant height, such as row spacing and between plant spacing and those kind of things.
Yeah, so plant spacing kind of varies a bit between different places that are growing it. Here in Tassie, we kind of aim for 150 plants per metre squared, and really that's about making sure that our stems are as thin as possible, because if you spread them out, the plant will get bigger too. And it's around the fact that if the stems are even thicker, we're going to have more trouble with dealing with them afterwards. So there's really not much work, there's kind of no work that's looked at PGRs on hemp. There was some work a few years ago that TIA did at Forthside that wasn't a PGR project, but they did try Uniconazole. And when I chatted to them when I was planning this, they quite openly said, don't put it on too late, otherwise it won't work. So that's kind of where it got to there. And then to that, a lot of PGR work in other crops, and I'm sure it happens with hemp as well, gets done in-house and it never reaches the public literature. So that's been a challenge for me. I've had to kind of draw on what we've seen in other crops to see what we could get here. Well, hemp's actually a pretty easy crop, which is why our farmers like it. It reaches row closure real quick, so you've got to get your herbicides on real quick. And they do have an insect problem, but we don't really run into any fungal problems. Well, touch wood, we haven't at this stage. And as far as I'm aware, Uniconazole is